I am Omale Jeffrey Jojo, celebrity mathematician. You're welcome to Tertiary Mathematics 1. Today we are doing introduction to a very powerful and most important branch of mathematics called calculus. And what is calculus? Calculus is the study of the rate of change or continuous change. That is what calculus is all about. Calculus is used in everyday life, in engineering, science, medicine, art class, a lot of them. You may not be solving problems, but the application of it, the equipment developed by it, is what we use every day. So let me start in this way. Before you understand the word this calculus, which is divided into two. Calculus. We have this. That's what we call differential calculus. Differential calculus. And we'll have integral calculus. Now, we're not going into it directly because there are some things you're supposed to understand to flow in this calculus. We'll have what we call trigonometry, that is the study of triangles. That's what we call geometry, the study of shapes. And there's another thing we call, and this stay the same place, algebra. That is the study of generalizations of arithmetic operations or the study of symbols. So we want to start with the trigonometrical identities for you to understand the concept of calculus. Calculus is very, very important. The engineering student will tell you how important calculus is. The medicine student will tell you, and calculus is the concepts, the most concepts used in data science and machine learning, such as derivatives, optimization, and integral. So as we go further, you understand better what we are saying. You understand better of what we are saying. Now I said that let's go to what we call trigonometrical identities. Trigonometrical identities. Now, what do we understand by this? We all know that sin² theta plus cos² theta is equal to 1. Yes. So, but let me refresh our brain. We have something like this. So we have this place to be A, B, and C. If this place is the theta, then we'll have this place to be small a, small c, and small b. Good. In our secondary school, there's what we call cos²t. You may have forgotten about it, but let me bring it back. There's what we call cos²t. Good. Cos²t, that means my sin theta will now be equal to opposite over the hypotenuse. This is the hypotenuse, this is the opposite over the hypotenuse. I have A over C. Then cos theta is equal to adjacent over the hypotenuse. this is adjacent and this is the hypotenuse. I have B over C. Then the same way, my tan theta is equal to opposite over the adjacent. Opposite over the adjacent. That is A over B. Now, how did I know that this place is the adjacent? This is the angle here. This is the longest side. This is the one that's attached directly to the angle, is the adjacent. This is the opposite, is facing the angle. Okay, but this is not where we are stopping. We say that if sin theta is equal to this and this is equal to this, it implies that sin² theta will now be equal to A² over B over C². That is it here. In the same way, my cos² theta will now be equal to what? B² over C². Good. Now, but we're trying to get this. That means if I add these two, look at it. If I add the two, that is sin² theta plus cos² theta will now be equal to what? A² over C² plus B² over C². Good. I think we're still moving and it's understood. Okay, if that is the case, there's what we call, there's one man in mathematics that we always remember when we come to trigonometry, Uncle Pythagoras. He was my classmate. Then I decided to go for business. Uncle Pythagoras is a very good man. He studies a lot. So he said by Uncle Pythagoras, he said that A² plus B² is equal to C². This is what he said. Now, if I'm to use this, it means that the whole of this C² is what is A² plus B². That is sin² theta plus cos² theta will now be equal to what? The LCM of this is what? C. C² and C². The LCM is C². Draw this. This the LCM. C² divided by C² is 1. 1 times A² is A². Plus C² divided by C² is 1. 1 times B² is B². Good. Now, if we have this, but A² plus B² from here, let's say equation star. From equation star, comma, A² plus B² is equal to C². Good. So I can now substitute here. Therefore, sin² theta plus cos² theta is equal to, I'll substitute for C², that means A² plus B² is C² over the LCM C². Now C² divided by C² is 1. Therefore, sin² theta plus cos² theta is equal to 1. So you put QED. QED simply means quod errant demonstrandum. But this one is a small proof. As we go further in all these things, you understand better. I think people, people who were in BDT engineering at Futo then, when I was taking differential equations, ODE, they will understand this because I took my time to teach them. Mr. Nwankaji Hillary can attest to that. That was back then at Futo. Now, once you have this, there are some important things that we are going to still check again. Remember, if I divide through by sin²t, divide through by sin²t. Now, this will give me, if I divide through, it will be sin² over sin² plus cos² over sin², which is equal to 1 over sin². So just this, there are two things you're supposed to know in this place. There's what we call cosec, and there's what we call sec, that is secant. Anytime I have 1 over sine will be cosec. 1 over cos is secant. Like this place, 1 over sine is, and 1 over cos, 1 over s, 1 over c. So please don't forget this. So supposing I divide this, that means I have 1 plus this is cot²t. Now if it's sine over cos, it's tan. But if it's cos over sine, that is inverse of sine over cos. If it's sine over cos, is tan. If it's cos over sine, is cotangent. That's why we have cos²t. Then 1 over sine, this s, that is cosec, is equal to cosec²t. This is one of the things from here, from this sin² plus cos² equal to 1. Then suppose I divide through, by cos²t. If I divide through by cos²t, that means what I'll be having is sin² over cos², right? Plus cos² over cos² is equal to 1 over cos². Now in this case, what we do, sine over cos is tan. So I have tan². Cos² over cos² is 1 plus 1 is equal to 1 over cos². And I said that when we have cos², that is sec², we have sec². So this is what we have in this line, right? But you know addition is commutative. I can say 1 plus tan² is equal to sec², just as I say, or I can rewrite this one, cos² plus 1 is equal to cos². I see the same thing because addition is commutative. Because you may see it in the textbook that this is cos² plus 1 equal to cos². I see the same thing. So this is what we have here. Then we'll proceed to another line, another trigonometrical identity. Now, we all know that from our previous secondary school, that sin A plus B is equal to sin A cos B plus cos A sin B. You understand? From our secondary school, we know that sine is a very good neighbor. Unlike some of us that are very wicked, you have food, you not give to your fellow neighbor. In this case, sine, you see, immediately sine carry the meet A. This is meet A. It's okay. Where's my neighbor? Neighbor, come and carry your own. Neighbor carry his own, which is B, cos B. The neighbor is the neighbor of sine. Cos is the neighbor of sine. Then he now went further again. He saw that place they were just getting things. It's okay. Neighbor, come on. I was the one that carried the other one first. Come and carry your own. He now called the neighbor. The neighbor carry the meat. Then him now carry the second meat. So he now came down that one again, the same sign. Uncle San is a very good person. Minus B. Now look. When he came here, see what he did. It's okay. Let me carry him on the same way. A. B. In this case, see what really happened here that they are using in this place. See it here. Now the minus, there's no adequate food. But in as much as there's no adequate food, you don't want to hide it. Some of you say, God knows that I only have 2 cups of garri. I can't give it to my neighbor. But now this negative in mathematics, negative is always, when negative is applied, it's always not. Okay. He carried the 1 cup of garri. He called the neighbor again, come and carry the second garri. Then he now went further. The one he saw now that is not sufficient. He still called the neighbor to carry first. Then he carried second. Can you see? Okay, the sign, it not change the sign. See, there's no food, he still put it. Now I want you to understand something. In sign, the sign does not change. And the sharing formula is the same thing. But now let's look at some of you who are neighbors. Even if you have abundance of food, you not give. See you are cursed. See it here. Now look at this man. In as much as the neighbor is hungry, see what you do. He first carry. Can you see? When he carried first, he not even called the neighbor. He still carried the second one. And immediately carry block the way. So that the neighbor can just eat maybe the remnant. The kings in the Bible, the wealthy king and Lazarus, the one from the table is what they will eat. So he now said, okay, he changed the form. He backed them. So the sign now changed to minus. It's okay, carry your own. No. Can you see? He first carry all before he allow even the second neighbor to see carry another one. This is the first neighbor, this is the second neighbor. He carry first. Then come to this one when there is no availability of so much food again. A minus B. See what he did? He came here. He still carry from here. Even as the food is not available, he still carry cos A, cos B. Now he now block them again. Change the sign. You see what he's doing? To first carry before you allow this person to carry. Can you imagine? This. Then, one no. From the beginning, we say that tan A plus B. Say the same thing as what? Sin A plus B over cos A plus B. Please listen attentively. Since there's A plus B as the angle and tan is sine over cos, I still repeat the same A plus B. And if this place is theta, I would have said sin theta over cos theta. If it's S, I'll say sin x over cos S. So what is here, I repeated it. But normally, tan is sine over cos. So that's where we'll do a little work. You get a little work there. Now look, we all know from here that sin A plus B. Sin A plus B is sin A cos B plus cos A sin B. That means my tan is equal to what? Sin A plus B. Sin A, I'm taking from here sin A cos B plus cos A sin B over, now look at it, cos A plus B, that is the denominator. Cos A plus B is what? Cos A cos B, cos A cos B, minus sin A sin B. And you said what I repeated is the same thing here. Sin A plus B is sin A cos B, which is sin A plus B, sin A cos B plus cos A sin B, sin A cos B plus cos A sin B. I came down here, they say it's all over cos A plus B. So what I have here is cos A plus B, which is cos A cos B, minus sin A sin B, which is here. Good. Now this is the same thing as what? Saying that divide through the whole of this by cos A cos B. Do you know why I want to divide by cos A cos B? Because it's sine over cos that can give me tan. And what they have here, what I'm supposed to have here, I'm not supposed to have sine or cos here. I'm supposed to have tan. So, and sine over cos is what can give me tan. So I have to divide through by the one that can give me tan throughout. It's only cos A cos B that I can divide through. That all of them will either be cos A or sin A sin cos A or sin B cos B. So look at it. I have sin A cos B over cos A cos B plus cos A sin B over the same thing, cos A cos B. Right. Now this one is over, that is equal to, over the same thing I'll do to the denominator, cos A cos B over cos A cos B minus sin A sin B over cos A cos B. Now what did I do here? This one I used to divide everything. The numerator says sin A cos B over this cos A cos B plus cos A sin B over cos A cos B. I use the same thing to divide the denominator, cos A cos B, here over the same cos A cos B, which I'm using as the one to divide. Then sin A sin B over cos A cos B. So what do I have? We all know that sin A cos B over cos A cos B is 1. You all are going to have 6 over 4, which is the same thing as 2, 2, 3, 3, 2. This 2 is 1. It's just like 1 times 3 over 2. So cos B is 1. So sin A cos A is tan. Is tan A. Right? It's tan A. Because sin A cos A is tan A. Just as we saw from here. Then plus. Now cos A is 1. So sin B cos B is tan B. Over. Now cos A cos B over cos A cos B is 1. All of them is 1. There's minus here. Sin A sin B cos A cos B. This one, there are two things. Cos A is not 1, is tan A. Sin B cos B is tan B. So what you have is minus tan A tan B. So this is what we have in this case. Therefore, this is supposed to be, we put A plus B. So therefore, our tan A tan B, therefore, tan A plus B is the same thing as what? Tan A plus tan B over 1 minus tan A tan B. Thank you. So we have to still look at another thing. What if this place is minus? If that place is minus, so what we'll be having is tan A minus B. And we all know that from here, tan A minus B, which is the same thing, let me follow it for you. Tan A minus B over cos A minus B. So the same way we started from here. Right? Now, if we have it in this way, we can still bring it here in the same manner that we have been using. That this thing is still the same thing as what? Sin A minus B. We say that sin will first take and give to the neighbor. That is sin A cos B. It doesn't change the sign. Minus, you first give to the neighbor here cos A sin B. We also know that we have a greedy neighbor. The minus will change. That is, and the first take all cannot give to the neighbor first. That is sin cos A cos B. He changed the sign. Instead of leaving it for the neighbor, he changed the sign to plus. Then now allow the neighbor to take sin A sin B. Now, you know, we said that we are to divide. For us to get tan is for us to get tan a sine over what? Cos. And this is the only thing we can use to get them. We divide through by this. Since a sine over cos, divide through by this one that can give us sine over cos. This one cannot give me sine over cos for to divide through. So what I have, I've said I've divided everywhere the same way, which is the same thing as equal to sin A cos B over cos A cos B minus cos A sin B over cos A cos B. Now this the same thing, the whole of this thing is over what? This is a long division over cos A cos B cos A cos B over cos A cos B plus, the marker, plus sin A sin B over cos A cos B cos A cos B. Now we all know that this very thing here, sine over cos is tan, cos B is 1, just as I explained using 4 and 6. So in this place, cos B is 1. It's just like 1 times sin A cos A. So this will give me what? This will give me sine over cos is tan. tan A minus cos A sin B. Cos A is like 1. I explain it there. But let me just, I say 6/4, which I have 2. For example, there is 3. There is 2. So this 2/2 is the same thing as 1 times 3/2, which is the same thing as 3/2. So this one cos A is 1. 1 times sin B cos B. So take note of that. Right? So this one cos A is 1. So I have sin B cos B is tan B. Tan B. Then over cos A cos B is 1. Then plus sin A cos A is tan A. Tan A. And sin B cos B is tan B. So now say therefore tan A minus B is the same thing as tan A minus tan B over 1 plus tan A tan B. Okay, so in this case we have gotten this.